All right, so now that we've got a couple functional groups under our belt, I wanted to talk about nomenclature with multiple functional groups. All right, so there's a lot of information in this table, but a lot of these functional groups we haven't learned yet. But I wanted to go ahead and include in this table all the functional groups that we're going to learn this semester. And so one of the most important things when a compound has multiple functional groups is determining which group has the highest priority. And we've already seen this a little bit, right? When we named alcohols, alcohols got special priority, and the parent chain had to include the alcohol, and then the alcohol would get the lowest number possible. But when we have multiple functional groups, not everything can get that special priority. And so this table lists in descending order their order of priority. So carboxylic acids of the compounds that we'll name always have the highest priority. And we're getting ready to learn aldehydes and ketones, and so they outrank alcohols. And so the aldehydes and the ketones will get the suffix of the parent. So for example, if we had an aldehyde and an alcohol in the same compound, the suffix of that compound would be named from the aldehyde. So if it was heptane, it would be heptanal. And then we'd have to name the alcohol as a substituent, right? It would be named like an alkyl group or a halogen. And so we'd have to give its locant, but it would go in front of the parent name, and we'd name it as a hydroxy group. Now, it may seem like there's a lot of information in here to kind of memorize when we get to the end of the semester, but it's not as bad as it looks, because in general, the higher the priority of the group, the more oxidized it is. If we think about a carboxylic acid, it has 3 bonds to an oxygen, right? So that carbon is very highly oxidized, whereas an alcohol just has 1 bond to an oxygen. And then the ketones and the aldehydes that we're getting ready to learn, they have 2 bonds to oxygens. An amine comes below an alcohol because we have 1 bond to an electronegative atom, but it's a nitrogen, and nitrogen is less electronegative than oxygen. When we go to nitriles, now we have a C triple bond N, so we've got a triple bond to a nitrogen, so that's more oxidized than an aldehyde or a ketone that just has 2 bonds to an oxygen. But then we go to an amide, we have 3 bonds, but now 2 of them are to oxygens. Esters and carboxylic acids each have 3 bonds to oxygen, so they're higher in priority. So basically, the ordering of the priority comes from how oxidized these functional groups are. The more highly oxidized, the more higher the priority. Now, a couple notes on some compounds that we've already learned about. Alkenes and alkynes essentially have equal priorities. Just whichever one is closer to the end, that will get the lower number. Also, even though these have lower priority than some of the other functional groups here, or most of the other functional groups here, they're never named as substituents. They're always named as a suffix, and we call that the unsaturation. And so in that case, if we have an alkene or an alkyne in one of these other functional groups, we'll essentially have 2 suffixes. And I may have talked about this earlier in some of the previous videos, but we'll do a specific example to see what that looks like. And then these groups down here, we've learned about all these already. We've done alkanes and halogens and ethers earlier this semester. These don't get any special priority, and they never get the base name. They're always just named as substituents, and none of them have any priority over any of the others. It's just whichever one is closest to the end, or is give us the lowest number, or if we have to, alphabetization would be used to differentiate between those compounds. But they don't get any special priority. All right, so I wanted to talk about the nomenclature steps that I go through. And these are basically the same as the steps that I've shown you in any of these other videos, with maybe a slight caveat that when we have multiple functional groups, and so going forward, I would probably do this step first, right? Identify what functional group has the highest priority. And so that's going to determine what the suffix is. And then it's also important for the other steps. So once we know what the highest priority functional group is, we want to determine the longest chain, right? With a couple caveats. The longest chain must contain the highest priority group. Also, if there are other functional groups, they should be part of the parent chain as well, even if that makes the parent chain shorter. And then this is not new, but if we had any ties, right? If there were two ways to make a heptane, we want to go with the one that will have the most substituents possible. Then we need to decide how we're going to number the chain, and the highest priority group that we determined in the beginning, that number should be as low as possible. If for some reason there was a tie, like if there was a ketone in the middle of the compound or an alcohol in the middle of the compound or something, then we go by the second group should have the lowest possible number, right? And this is regardless of priority. Once we've assigned the highest priority group, the priority of all the other groups doesn't matter. Essentially, everybody's equal at that point after the highest priority group, right? And then if there's some sort of tie, and I think this happens, maybe more frequently in cyclic compounds, we would use alphabetization if the numbers are going to be the same. All right, and then the last two are no different than anything we've done, right? Once we've numbered the chain, we'll put the substituents in alphabetical order. We'll give the locants of each of the substituents. And then, if necessary, we'll also put the stereo descriptors. So this would be R or S or E or Z or cis or trans in the very front of the name. So there is an appendix at the end of our textbook that talks about naming compounds with multiple functional groups as well. And one of the things that I like that they did is, right, they kind of broke the name down into 5 parts. So we have the parent name, this can be heptane or hexane or whatever. We'll have potentially the unsaturation if we have alkenes or alkynes. We'll have the suffix if we have some other functional group. The substituents go before the parent, and the stereo descriptors go before everything else. Okay, so when I want to name this compound, the first thing I need to do is decide which functional group has the highest priority. So I have an alcohol and a carboxylic acid. Carboxylic acid is always going to have the highest priority, but we can also just compare, right? I've got 3 bonds to an oxygen versus 1 bond to an oxygen. This is much more highly oxidized, so this group is going to get the highest priority. So then when I'm determining my longest chain, it has to include the group with the highest priority. And so I might say, well, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll have nonane, and then with the carboxylic acid, it would be nonanoic acid. But when we're determining the longest chain, if we have any other functional groups, we want to be sure that we include those in the longest chain as well. So if I go with the nonane, that won't include the alcohol. So instead, I need to go 1, 2, 3, 4, 5, 6, 7, 8. And I guess I've also done the numbering as well. The carboxylic acids basically always get 1 because they have to be on the end, and it's the highest priority. So I need to start the numbering from this side rather than this side, regardless of where all the other substituents are. All right, so then the substituents I have are a 4-methyl. I have an 8-hydroxy. And I have 6-propyl. And then with my carboxylic acid here, that's going to make the parent chain octanoic acid. And I know we haven't learned carboxylic acids yet, so I'm not going to make you responsible for knowing these suffixes yet for carboxylic acid, but if you have that table and you know what the suffix should be, you should be able to name this compound. And so then I'll put the substituents in alphabetical order. So it looks like we're going to have (8-hydroxy), 4-methyl, 6-propyl, and then because the carboxylic acid basically always has to be at the end, we generally don't give a number for it because it's understood that it's going to be number 1. So it would be 6-propyl, and then we'd finish it off with octanoic acid. Now, I do have a couple of chiral carbons in this molecule, but because I haven't indicated the stereochemistry, it's impossible for us to determine whether they're R or S, so we can leave off the stereo descriptors in this case. Okay, here's another example that I wanted to talk about where we're going to have two suffixes. So we have an alcohol, which is a higher priority than an alkene, but we have to name the alkene as a suffix, and then the alcohol gets the higher priority, so it's also going to be a suffix. So we'll see what that looks like. So we've already kind of talked about the alcohol has a higher priority than the alkene, so this is the highest priority group. So then when I'm numbering, the alcohol needs to have the lowest number possible, so I'm going to start from this end. So I have 1, 2, 3, 4, 5, 6, 7, 8. And then this compound has a 2-methyl, and then the alkene is going to start at carbon 6. And so what that would look like is it would be 2-methyl, and then normally when I'm doing an alcohol, this would be 2-octanol, but when I have to also name the alkene with a suffix, if I put a number in front, it's a little unclear whether I'm talking about the alkene or the alcohol. And so in this case, when I have multiple suffixes, I'll put the number just before the suffix. And the unsaturation comes before the higher priority functional group. So it's going to be octan 6-ene 2-ol. So the 6 comes just before the unsaturation, and then the 2 comes just before the suffix of the higher priority group. All right, now we've got most of the name, but we need to be careful if we have any stereo descriptors that we need to talk about. So this carbon's not chiral because I've got 2 methyls coming off, but I do have an alkene, and so I should indicate whether it's E or Z or cis or trans. Now, because I have 2 hydrogens here, I could go with trans, or since the 2 higher priority groups are on opposite sides, I could go with E. So I'm going to go with the EZ designation, and so I'm going to call it E 2-methyl octan 6-ene 2-ol. All right, so here we have a cyclic compound, and I have a halogen which doesn't get any special priority, an alcohol which is higher priority than the halogen, but then I have 2 bonds to an oxygen here, and so this ketone is going to get higher priority than the alcohol. And so my base name is going to be cyclohexane, and we're getting ready to learn aldehydes and ketones. So I have a specific video on naming those, but if you go to the table, you'll see that the suffix for a ketone is -one. So this would be, my base name would be cyclohexanone. Now it has the highest priority, so for the numbering, this has to be number 1. Now I can go 1, 2, 3, 4, 5. I can go 1, 2, 3, 4, 5. So either way I number it, it's going to be the same. And we don't get any special priorities after the ketone. So even though the alcohol is higher priority than the bromine, it doesn't matter. And so now I have a tie. Either way I go, I'll get the same numbers. Neither one gets any special priority. So then next we would go to alphabetization. So because bromo comes before hydroxy, we'll number in this direction. So my numbers will be 1, 2, 3, 4, 5, 6. And so I can worry about the stereo descriptors in a second, but then putting my substituents in alphabetical order, I have 3 bromo, 5 hydroxy, and then again with a number. We talked about this with carboxylic acids because they have to be on the end. The 1 is understood. Again, in this case, because the ketone has the highest priority, it's understood to be number 1. So generally, we'd leave off the number of the ketone. And so then it would just be cyclohexanone. Now we also have to worry about stereo descriptors. And so in this case, they have shown us the stereochemistry, and so we do need to assign the configurations. So for carbon number 3 here, the bromine is going to have the highest priority. And then, these two carbons are tied. They're both CH2. So then I go to this one. I have 1 bond to an oxygen versus this one, 2 bonds to an oxygen. So this is going to be priority 2. That's going to be priority 3. The hydrogen's already in the back. And so I can see I'm going clockwise. And so carbon 3 is going to be R. Switch to a different color for for carbon number 5. The OH is going to have higher priority. So that will be 1. I then have a CH2 and a CH2, so they're tied. I then go one further away. A bromine has a higher atomic mass than an oxygen, so two and 3. And so again, 1, 2, 3, I'm going clockwise. The hydrogen's in the back already, so that compound, or that carbon rather, is also R. So when I put in the stereo descriptors, I'm going to have 3R, 5R, 3-bromo, 5-hydroxy, cyclohexanone. Okay, one last example. So I have a halogen, it gets no priority. And then I have an alcohol and a ketone again. So the ketone is going to get the special priority. Then for the numbering, where I could go 1, 2, 3, 4, or 1, 2, 3, 4. So neither one will distinguish from one another. So then I want the next group to get the lowest number possible. And there's no special priority. So after we've assigned the highest priority, now essentially the alcohol and the halogen or alkyl groups or whatever are equivalent. I just want it to be as low as possible. So here I would start with the first substituent other than the ketone as being 1. Here it would be 2, so I should start numbering from this end. So it should be 1, 2, 3, 4, 5, 6, 7. Now in this case, I'm not cyclic, and so I do need to indicate the position of the ketone. So my parent and its suffix is going to be 4-hexanone. I also have a 6-hydroxy. I have a 1-iodo. And so putting everything in alphabetical order, I have 6-hydroxy, 1-iodo, 4-hexanone. And again, I do have 1 chiral carbon, but because they didn't indicate the stereochemistry, I can't give the stereo descriptor. And so this is what we would do for the final name.